Alright, we're going to talk about chords today. Okay, what is a chord? A chord is a segment with endpoints on the circle. Okay, so any segment with endpoints on the circle. So that's a chord right here. We'll call that chord AB. Endpoints are on the circle. This could be a chord right here. Okay, this could be a chord right here. Alright, the diameter is technically a chord because the endpoints are on the circle. Okay, now there's specific rules with chords. Specific rules with chords. Alright, so let's draw up another circle here. Alright, the first rule we're going to talk about is if two chords are congruent in a circle, then the corresponding minor arcs are congruent. Alright, and this works with the converse too. Alright, if the minor arcs are congruent, then the two chords are congruent in a circle. Alright, so if I have a chord here and a chord here, and they are congruent, then AB, and we know AB is congruent to CD, then arc AB is congruent to arc CD. Alright, that's the first rule with chords. Alright, so if we look at an example, we have TU, chord TU is congruent to WV. Therefore, arc TU is congruent to arc WV. Alright, and if TU is 13, then, well, we know TU is 13, W is 13, and if arc TU is 79 degrees, then measure of arc WV is 79 degrees. Alright, so therefore x equals 79 degrees. Okay, so that's the first rule with the arcs and the chords. Alright, let's look at some different examples. Alright, we said the converse is true, so if this arc is congruent to this arc, then this chord is congruent to this chord. So 2x minus 12 equals 36. Add 12 to both sides. 2x equals 48. And we get x equals 24. Alright, next one. We know that the chords are congruent, so their arcs are congruent. Alright, so if this is x right here, then this is x. And since this arc right here is 38, well, what do you know? You know x plus 38 equals how many degrees? 360. Alright, 2x plus 38 equals 360. 2x equals 240. Oops, sorry. 222. So x equals 1, 1, 1. Okay, last one. Okay, we know that MP is congruent to RQ, therefore their arcs are congruent. So RQ is 76. Well, how does that help us find x? X is a central angle. If you guys remember, central angles are equal to the arcs they intercept. So x equals 67 degrees. Next rule with chords has to do with the diameter. Okay? If a diameter is perpendicular to a chord, alright, and here's the symbol for perpendicular, the upside down T. Then it bisects the chord and its arc. Alright, so both the arc and the chord get bisected. Alright, so let's say we have diameter that is perpendicular to the chord. Okay, we have the diameter is AB, and the chord is CD, and we have E as the intersection point. Okay, so this tells us if CD equals 16, since it gets bisected, then CE equals 8 and ED also equals 8. Okay, but also if the measure of arc CD is 120 degrees, then measure of arc CB is 60 degrees, and the measure of arc BD is 60 degrees. Alright, because they're both bisected. Okay? Now, conversely, this works too. So if you notice that a chord is bisected, okay, then we know it's perpendicular. Or if we see that an arc is bisected, then we know it's perpendicular to the diameter. Okay. Let's look at an example. Okay. Well, we're going to say the measure of arc AC is 55 degrees. Find the measure of arc AB. Okay, and then we're going to do AD equals 8. Find AB. Alright, so what is, if the measure of AC, arc AC is 55, what's the measure of AB? So AC is 55. Alright, and we see that it's perpendicular. So the measure of BC is also 55 degrees. Therefore, AB is 110 degrees. Okay, same thing. AD is 8. Therefore, DB is 8. So the whole thing is 16. Oops, went backwards. All right, last rule with chords is we have two chords. Let's make this a little better. And we have the center. And the center is equidistant from the two chords, then the two chords are congruent. Okay? The two chords are equidistant from the center, then the two chords are congruent. Now, they would have to be perpendicular to show that they're equidistant. Okay? All right, so therefore, if we have our two chords, therefore we know that AB is congruent to CD. All right, let's look at a couple examples that we might see. I'm going to draw one in here. And we're going to say that if ZY equals eight, then find UZ. Okay, so that's one of them. Okay. All right, so we know that VW is congruent to ZY. All right, so I'm not going to really do any examples, all right, because it's just basic. You guys got to know that concept. All right, I'm going to throw a tough one in for you, though. Okay, so if we have a segment, okay, from the center circle to the outside, what do we call that segment? Well, we call that the radius. All right, how can we find the radius here? All right, UZ is the radius. So how can we find the radius? Well, we know that this distance is 8, okay, and we know the chord. All right, our chord is also 8. Now, it may not look like it, so whatever. All right, so be it. All right, we know that this is perpendicular to our chord, therefore our chord is bisected based off our second rule. So this right here will be 4. Okay, and what do we have? We have a right triangle. And we could use the Pythagorean theorem to find the radius. So a squared plus b squared equals c squared. All right, 8 squared plus 4 squared equals the radius squared, or UZ squared. So 64 plus 16 equals r squared. We get 80 equals r squared, square root both sides. We get r equals the square root of 80. And we could simplify that. Perfect square that goes into it is 16. 16 times 5 is 80. So we have 4 radical 5. All right, the radius is 4 radical 5, or UZ equals 4 rad 5. All right, so you might see that problem in the future.